Okay, today is going to be 5.6, which is called the remainder and factor theorems. Basically, where this gets complicated is this is the lesson where you start using synthetic division for something other than just synthetic division's sake. Okay? The problems earlier in the chapter, we did synthetic division just for some random reason. I really don't know why, but Mr. Mormon told me to do it, so I'm going to try my best to do it. Okay? Here, we're actually going to apply it and do something with it. Okay? Which is honestly one of the cooler lessons of the year, if you really think about it. Okay? And once you put together the dots. To start, I want you guys to do this problem. Alright? I want you guys to do f of x equals negative 3x squared plus 5x plus 4. Find f of 3. Alright, you plug in 3 for x. 3 squared is 9 times negative 3 gives you negative 27. Plus 5 times 3 is 15. Don't know how that happened. Plus 4. So negative 27 plus 15 plus 4 gives you negative 8. Cool. All right, now, watch this. I'm going to do something completely different and out of the blue. Just to segue that, I'm going to do it in blue. Ha ha. Mr. Warren, that was stupid. Negative 3, 5, 4. Yes.
Where did you get the 3 from? Why isn't it negative?
That's the thing. That's the thing, okay? So, the first application of synthetic division that we are going to use is called synthetic substitution. That'll be on the next slide, okay? There's basically two applications we're going to use, all right? Obviously, you have to know how to synthetic divide to use both of them. The first one, you don't switch the sign. So since I asked for f of 3 ahead, 3 is what you plug into your side box. Okay? And then the remainder that's down here is equal to as if you had plugged it in here and simplified. Alright? Now, this may not seem, let me pull up, everybody cool with that? And yes, that works for every single one. No matter how big, how small, whatever. Alright? What you need from this slide basically is the bottom right here. Alright, the actual definition is in there. The top box is pretty confusing, so don't worry about it. Alright. Like I said, this is called synthetic substitution. Alright? Basically what it does is it takes a number, you synthetic divide it throughout a polynomial, and then you look at the remainder. That remainder result is going to be just the same as if you had taken that number and plugged it into the polynomial and evaluated it. Now, for one like we just did, where it was negative, what? Rochi, scroll back down to it. What was it? Negative 3x squared plus 5x plus 4. For one like that, you can make the argument where it's not very helpful. All right? You know, you might be like, well, Mormon, this is stupid. Let's just plug it in and be done. That's why I'm going to ask ones like that. 3x to the 5th plus 7x to the 4th minus 8x to the 3rd plus 2x to the 2nd minus 8x plus 5. Find f of negative 2. Okay? Don't do it. I have no idea what that is. I just made that up, okay? But that's one that you're going to get asked. Okay? And instead of plugging that negative 2 in, here's what you would have to do. All the way, you plug that negative 2 into each individual x. So that means you're writing out 6 terms again. You're taking negative 2 to the 5th power, to the 4th power, to the 3rd power, to the 2nd power, Then you're multiplying those results by 3, 7, negative 8, 2, negative 8. And then you're adding all of those numbers up with 5. That's the old way. Or you could put negative 2 in your side box, rewrite your coefficients, bring it down, run it through. It's much faster. Once you get past, and it says that down there at the bottom, it's a convenient way to find the value of a function, especially when the degree of a polynomial is bigger than 2. Okay, squares is not really too helpful. You know, just square it, plug it in. You can probably do it in your head. Once you get into cubes, fourths, fifths, this stuff, this becomes such a quick and neat shortcut. It's amazing. All right, any questions so far? Everybody good? All right, let's try a couple. The hard part of today is going to be remembering when you switch your sign and when you don't. All right, Amanda.
Do we put the x squared in?
Yes. Okay. That rule still applies. Okay. You still have to put in any missing any missing terms. There we go. So
It's easier to do it the other way.
you think?
Or did you plug in your calculator?
Well, what if I take it away?
Oh, you're gonna take it right now?
I'll bring it up and I will.
Well, then I can't do this. It's supposed to be like curved and not a box because they're different, or?
No, that's just the way I wrote it. I was just lazy. Okay. So 3 times 4 is 12. 12 minus 2 is 10. 10 times 4 is 40. 40 plus 0 is 40. 40 times 4 is 160, which gives you 165. Off the top of my head, what, 660, right?
6.
Add it up.
6.
662. 662 is your answer. So here, you are looking for the remainder. All right? The remainder number is your answer. That's where today is tough, okay? It's all synthetic divisions. You just have to remember, when do I switch my sign, and what answer am I looking for? Where this way really helps is with your negatives. Okay, if you're evaluating with a negative number, now you don't have to worry about all of your negative power rules. Okay, so -1 here, 5, 4, 3, 2, 1, none. Okay,
Why did you put others there?
because there's no x to the fourth.
No, then the second one.
There's no x either.
Oh.
See that? Okay, so 4, -4, -4, 4, 6, -6, -5, 5, 5, -5, -6. See how quick I did that? Do you really think plugging -1 into 3 x's and then doing those powers and then adding them all up is faster than what I just did?
Well, if you do it all in your calculator, I'm sure so.
What if you could?
Second topic of the day is what's called the factor theorem. All right, now, the factor theorem is based upon the first way we learned how to do synthetic division. Okay, where I give you a polynomial like 2x cubed minus 3x squared minus 17x plus 30, and I give you a binomial to divide it by, which is x plus 3. All right, it's based off of that. I'm going to put up the synthetic division to it, and it's that. Okay? All right, just if you would run it through, that'd be it. The remainder in this case is what? 0. All right, everybody see that? Remainder is 0. Now, when you did back in the day, and you did something like, 24 divided by 3, and you got what? 24 divided by 3. 8. Okay. You got 8. You got 8, remainder what? 0. Why did you get a remainder of 0? Roach? You're missing one key word. It goes into that number evenly. Okay. 3 goes into 24 evenly. Expand on that to polynomials now. Okay? The binomial x plus 3, when you divide it into 2x cubed minus 3x squared minus 17x plus 30, gives you a remainder of 0. which tells you that that binomial divides the polynomial evenly. Okay? You have to change your logic here. Okay? You're not just doing nice numbers. You're doing polynomials now. Since it divides it evenly, okay? So then let's go back to our first example, 24 and or 3. Since 3 divides 24 evenly, that makes 3 a what of 24? A factor. 3 is a factor of 24. Same logic applies here. Okay? That means that x plus 3 is a factor of this polynomial. X plus 3 is one of the binomial factors that if you wrote them all out, when you multiplied them all together, would give you 2x cubed minus 3x squared minus 17x plus 30. Okay. What you're doing is dividing by it. You are getting a remainder of 0. And it's giving you a polynomial in the end. Okay? Depressed polynomial, I'm pretty sure, is one of your vocab words. Alright, if it's not, it should be. Alright, depressed polynomial is the result of dividing a polynomial by one of its binomial factors. The key to this problem is the remainder is 0. Okay? The remainder is 0. As long as you did it right, the remainder will always be 0. There isn't a case where I give you a polynomial and a binomial and they don't correctly divide to be 0. If you don't get 0 on these examples, you are doing something wrong.
So all factor theorems should have 0?
All the directions will say factor, usually say this. It'll say factor each, one factor has been given. Those should give you a remainder of 0. Alright? Everything good? Okay. So once again, this kind of switches gears. This is how you have to think about your syntactic division, okay? You basically have 3 different types. Type 1, you just do it. Okay, 5.2, you just do it. Type 2, you're evaluating functions. You use the number you see. Type 3 is this. Okay? Any questions? Please?
So if
Yes. If I give you a binomial like this, you change the sign. Okay. Everybody good? The first way you're plugging it like is the first way you're like evaluating, basically. Okay, and you're just getting a number at the end for your remainder. This way you'll see how this way is different here in a second. Okay, everybody good? Okay. So here's what we're going to do. Determine whether x minus 5 is a factor of x cubed plus 7x squared plus 7x plus 15. Then find the other factors of the polynomial. Okay, so what you do is you take this polynomial, set up the coefficients like you would. 1, negative 7, 7, 15. Since it's in a binomial, you want this guy's opposite, so that'll be 5. Okay, same setup, nothing changed. Okay, run through your divisions. Bring 1 down. 1 times 5 is 5. Negative 2. Negative 2 times 5. Negative 10. Negative 3. Negative 15. 0 is your remainder. Okay. So we did it right. Alright? We got 0 as a remainder. Remember, like I said, these you will get 0. There's not like a no solution case where you can possibly get 0 or something other than 0 as your remainder. If I'm giving you these problems, they work. Okay?
What's it say? OPC?
Do what?
What's it say about the negative one?
Opposite. OPP. Alright. Now, 2 more steps. Number 1, rewrite your depressed polynomial. So x squared minus 2x minus 3. Okay? Rewrite that. And what are we trying to find here? What's the directions at the end say? Find the other factors. Where are the other factors of the original polynomial hidden at? Right there. This guy. Factors. Okay? So, you're factoring, coming back again. So, you need an x here, and an x here. You need two numbers that multiply to -3 and add to -2. -3, +1. Those two factors are your answer. The biggest mistake maker on these is honestly what it's always been. Okay? Forgetting to switch your signs on, whoops. There we go. Forgetting to switch your sign on the binomial right here. Okay? Forgetting to write that arrow. Some of you got some of you on that quiz. Okay? I told you that's the most important stroke right there. Because some of you forgot it. And then some of you messed it up. Okay, so 1 times 2 gives you 2, which gives you -5, which gives you -10, which gives you -6, which gives you -12, which gives you 0. They won't all factor that easy. Okay, so x squared minus 5x minus 6 is your depressed polynomial. Factor that, x minus 6, x plus 1. Okay, and when I say that, this can be anything. It won't always be a nice little trinomial you've been factoring for 3 years now. This could be anything we've done so far. This could potentially be a cube, a difference of cubes, a sum of cubes. This could potentially be a grouping if I set it up that way. This can be anything. All right, anything we've done up to this point. So your factoring has got to be really, really good. Okay? No. All right, homework for tomorrow is going to be this. Page 355. 8 through 14 even, 17 through 22, and then number 25.